Hi, all. Thank you for joining today's session. I hope you all had a great weekend. So, we are resuming our sessions with Cisco ICE. And if you have been following the classes, so you might know that we have been working on Cisco ICE different concepts. Like we started with introduction of Cisco ICE. Then we have understood the deployment, how it is deployed. We were about to do the installation in the last session, but since it was consuming a lot of time, so we were not able to do it. So today we will do the installation as well. And also we have learned about the basic terminologies that is being used in the Cisco ICE. Apart from this, there are many things like the radius, what is radius, and we had started what how the radius flow works and different authentication method. We came across a terminology called as EAP, and we understood that EAP is used to carry the credentials, and it is not the one that is going to take the credentials from point A to point B. For that, you need either the native EAP or else the tunnel deep. Native EAP is MSCHAP v1, MSCHAP v2, then tunnel EAP like the PEEP, right? Protected extensible authentication protocol, and native EAP is nothing but MSCHAP v2 or MSCHAP v1. Okay, so just to refresh, I have explained this to you as an introduction of today's session. Let's get started with our today's agenda. So today I would be continuing with the .1x flow, and then we would be looking at what is a AVP, and we would be going through different authentication protocols that .1x has got. Okay, so we would be looking into those aspects, and also we will go for the different host modes we will understand, and licensing obviously, and then once the licensing is complete, so then we will go for the device administration. So hopefully we should start the device administration introduction. So let's try to reach there. So before jumping into the theory section, we will just try to install the Cisco ICE that we were doing in the last session. All right. So let me switch my screen share to the RDP machine where I have got the Cisco ICE. This is our Cisco ESXi, sorry, the VMware ESXi, where we are installing our Cisco ICE. As I have told you in the previous session, Cisco ICE can be installed on the AWS cloud, or it can be in any other cloud, and also it can be installed on the VMware, just like we did it on the 9800. And also it is available as an appliance model as well. So it all depends on the capacity, how much capacity it can store, how many clients it can serve. So that is what the Cisco ICE will do. And also Cisco ICE, we have learned there are different personas of Cisco ICE, and what is the what each persona is doing and what is the flow also we have understood in the last session. So as you know, for installing any virtual machine for that matter, you just need to go right click here, and there are two ways to install the iOS, install the application. The benefit of using ESXi, as you know, we can install multiple softwares on a single hardware. That's the benefit. And similarly, as you can see, there are multiple VMs, virtual machines that are installed on the ESXi. And for installing any virtual machine, or you can say any application, there are two ways. Either you can use the ISO file and install it, or else you can use the OVA, Open Virtualization Archive, or Open Virtualization Format. We know what exactly that is, and OVA is basically, it describes the hardware parameter where you no need to select manually the RAM, the storage, and the CPUs and all. So it will be inbuilt and it's a tested one as well. So it is always safe to use OVA rather than going for a manual installation with the ISO file. So we just need to go to the ICE. We just type a virtual machine name, select a OVA file that I have got here, that is ICE 3.1. Open and click on next. Next. Let me give a different name. Already ICE is there. So I will say ICE Lab 5 maybe. And next. Oh, I need to choose. Open. Next. And you choose the storage which has uh, lot of storage left. So as you can see, it is 260, 500. So I will just use this three here. Next, this is my, I hope you know this VM networking. So it is a networking internal to the VMware. That is hypervisor itself has got some um, networking inbuilt. So normally when you have the box, you can use all the default values unless you have some expertise on the VMware. You know what vSwitch does, you know what port group does or port does. Okay, VM NICs. So all those concepts are clear. You go and configure it. If not, you can leave it default. It will automatically install with the default values. So it is for evaluation, and in the lab environment, you can go for the thin. If you are doing it for the production, use thick. Okay, power on automatically. Yes. Next, finish. Okay. The problem with this is it's taking a lot of time to install. If you're looking at the recent tasks here, so it is running like 0%. To power it on, I have to wait for long time. So for your ease, what I have done is once everything it goes through, it installs the disk, right? So I have prepared it and I have kept it over here. Okay. So once it loads the image, so this is what you see next. Okay. And also I have been installing it here as well. I have okay, so we have here also, right? So which we just spin a VM now, right? So that is present here. So once it is up, we can power it on and I will show you. Okay. But let's not waste our time since I have already set up for you. So let's try to move on. I have to change this name, okay? Because maybe other ICE servers also with the same name. So let me rename it. So I will say ICE Lab 4 and rename. Let me click on this. So it's a first time setup. So in that case, you just need to type setup as it is prompted, enter. We need to type the host name. So the host name is ICE Lab 4. You might have doubt like the VM name that you give here is that needs to be the same here. So that's not required, but it is best practice to have both sides same name. Okay. Entire host name IceLab 4. It's a very small thing, but I thought I will just tell you that just in case. Then the IP address is 10 dot, 150 dot 1 dot 7 dot. I will make it as 60. Okay. We'll give dot 60. So as you know, our architecture, lab architecture, we got WLCs, we got APs, WLC in the 150 network, and also we are putting ICE also in the same network. APs in 100 or 200 network we have put. Then the clients we are putting in VLAN 10 like 192.168 dot network. So in continuation with the same thing, so I am putting ICE in 150 network. Okay. 0. Okay. 150.1.7.1. Enter. Do you want to configure IPv6? No. DNS default enable domain. Just say is sharma.com. Primary name server. So I will say 115.1.7.103. I have a DNS server built in. Okay. In this same ESXi. So that's IP is 103. I'm just going to use that. Secondary DNS server. I will just find it on Google DNS. Please enter a primary. Okay, sorry. It's asking. Yes, I want it. 8.8.8.8. Enter. Tertiary is not required for me. Enter the NTP server name. NTP server name. I'll just give some internet NTP server. In dot pool dot ntp dot org. Add another. No, I don't know. Enter system time zone. So I will say IST. IST is not there. Just keep it UTC only. Enable SSH. Yes. Enter username. So I'll keep it as admin only. Password sanfran at 1234. Enter. Sanfran. So it's coming up. So it will take some time. And it's trying to ping. Let me check if the DNS is up. Pinging the primary name server failed. Okay. Okay, the AD is down. So let me power it on. So this AD VM, so this is my DNS server that I have built. So why it went down? Okay, it is up now. So let me click on this. Guest OS and keys. Control Alt Delete. Login. DNS gmt.mfe. DNS. This is the forward lookup zone that I have created. Okay, so here I am going to add that name. That is, let me right click on this. New host. I have given icelab 4, I guess, right? So that has to resolve to 150.1.7.1, oh, sorry, 60. 60 is the IP that I have given there. So create a PTR record. Basically, it will create a reverse lookup. Forward lookup is host name or the FQDN, that is host name plus the domain name to the IP address. Reverse lookup is IP address to domain name, sorry, FQDN. Okay, that's what. So once I create the forward lookup, automatically it creates a reverse lookup. Add host successfully created. So if you go to the reverse lookup here, so that will also be there, automatically created. So 60 you can see. Okay, the IP address will resolve to the FQDN. And if you want to check, you can do a NS lookup and check out the domain. So now let's go back and try to ping now. So now it should ping. Yeah, so this is right. Pinging the primary name server. It should work now. Okay, so it passed, I guess. So that's why it's moving with the further steps. Testing VM disk IO performance. So once the image gets booted up, so it is going to prompt you to enter setup. And once you enter setup, there is a dialog that is going to open where you have to enter the inputs. And once you enter the input, then it is going for the installation of the different components in the Cisco ICE. And once all the installation post scripts, everything is completed, so then we get a prompt to enter the username and password. So pretty straightforward, okay? It will take like 5-10 minutes, I guess, maybe 15 minutes. So let's not waste the time and go back to the theory section and complete the remaining concepts that we have got. So again, we will come back after 15 to 20 minutes and then we will, we will continue the configuration. All right. If you want me to repeat something, so please let me know. I can do that. So I am doing this just to save your time. So we have been learning about the Cisco radius. In the previous session, we have learned the basic flow of the radius, how exactly the radius is going to work. So in this ICE architecture, so we got supplicant, we got authenticator, that is a NAD or a NAS box, that is network access device or network access switch, right? And then the authentication server. As I explained, between the supplicant and authenticator, it is a EAP protocol. Okay, inside it has multiple things, but on a high level, it is a EAP. So EAP on the from the NAD box to the authentication server, it is EAP. Then you know, EAP does not carry it has the credentials with it, but if it wants to take it from point A to point B, it needs some other protocols like MSCHAP v2 or PEEP, right? Like that. And then on top of that, it is a radius between the authenticator and the authentication server. We know this, plus the Ethernet encapsulation, everything will happen. So ePOL start message is gone from the supplicant to the authenticator, or normally the authenticator sends ePOL request to the supplicant to identify itself in the network. For identifying itself into the network, so identity is the username that the supplicant is going to send to the authenticator, and the radius is going to forward that request, the authenticator through the radius protocol, it is going to forward that request to the authentication server, that is Cisco ICE. Or else you can be using some Juniper application or any other identity server you might be using. So it is going to send to that. So this radius server is going to respond with a radius access challenge if you're using MS-CHAP v2. Okay, if you're using MS-CHAP v1 as a protocol here initially, so then both the username and password will be sent at single go. But since it's a MS-CHAP v2, so first it is going to send the username, then the authentication server is going to accept that request, and it is going to send access challenge. So access challenge is basically it is trying to get its uh, uh, you know password. Okay, but here you can see radius access challenge, eep radius request peep. So then eep response peep. Here the peep protocol they are being using, not MS-CHAP v2 but peep. Okay, it's a tunneled protocol. So radius access request. So here in this, it will carry the credentials. And once that is done, radius access request access accept. So this is the authorization phase. Okay, where you are getting the VLAN and the DACLs and all. So .1x is delivery mechanism, and it does not provide the actual authentication mechanism. When utilizing .1x, you need to choose an EAP type. Okay, this is what we are talking about. .1x EPOL is a delivery mechanism, and it does not provide the actual authentication mechanism. Authentication mechanism is with the EAP type. It is an authentication mechanism such as transport layer security, EAP TLS or PEEP, which defines how the authentication takes place. I hope this concept is clear. So here it is you have a breakdown of what authentication phases, authorization phases, and the accounting phases. In the authentication, you can see what all things are happening. In the authorization phase, it's accepting the request. Radius is accepting the request, and it is going to send the WLAN, VLAN, and the DACLs and all. And then once that is completed, then the accounting phase comes. Okay, so we will learn in the TechAx and all how the accounting happens. Radius flow. This flow shows how authentication process moves between the client and the authenticator. Whatever we talked about, same steps has been mentioned here. Let's read the main points. Like the client starts sends authentication EPOL start, then EAP identity request is sent from the authenticator to the end device. And for central authentication, the WLC is the authenticator. For the Flex Connect, local switching. Okay, local switching, the AP act as a authenticator. Okay, either for the central switching or the local mode. There are two modes, right? Local mode and Flex Connect mode. And in Flex Connect mode, two kinds of switching: local switching, central switching. Okay. In the central switching, obviously central authentication will happen. The WLC is the authenticator. While in the Flex Connect, in the central switching, yeah. In the Flex Connect local switching, the AP acts as the authenticator. The client responds with identity, which is forwarded by the authenticator. Radius server suggests one or more EAP methods. The client chooses the method for authentication. Okay, that negotiation also happens. So there is a section in the Cisco ICE that is called as allowed protocols. Okay, we will learn about this when we are configuring. Okay, allowed protocols. So allowed protocols like the the client, the supplicant is going to go for the .1x, right? In the .1x also, you should be using some protocols like MS-CHAP v2, EAP TLS. You can use PEEP, you can use CHAP, you can use PAP. Okay, multiple protocols are there. So what protocols the ICE should expect, so that or what has to be negotiated, right? You have to check that protocols that are supported in the Cisco ICE. Okay, that we will see while configuring. WPA keys are changed for encryption, and the authenticator sends accounting packets with session information to the Radius server. So this is an important point, like how the these transactions are secured, obviously by using the tunnel protocol, EAP TLS and all, and also on top of that the encryption is being used. Okay, that is through WPA, wireless protected access keys. WPA2, WPA3. So with that, the key exchange is happening, and that is how it is encrypted. For encryption, we are using this. I hope that is clear. When the device is going to send, when the authenticator, that is an ad box, that is a WLC or a AP, is going to send a request to the ICE. So here is where all the magic happens. Here is where the ICE comes to know about the device that is going to connect. Okay, there will be some vendor specific attributes. There will be some attributes that the ICE will learn about the client through DHCP probes. It will learn through some other protocols like HTTPS or through other protocols. It is going to learn about this device. So that is how it is going to profile the particular device. This is called profiling. So we will learn in the profiling section more about this. But just to give you an idea, so how the profiling is going to work is, so this device, so what software it is having, what is the vendor, what is its IP address, what is its MAC address. So all these things are carried by the AVP, that is attribute value pair. Okay, attribute value pair. Attribute value pair, these are the key value pairs used to exchange information between the radius client and the authenticator. Radius client and the radius server, sorry. For example, it will be like a username. So these numbers are important. Okay. So these numbers say what that field is. I will show in the next slide, I will show the communication or the packet. When we open the packet, so what all things is there? Okay, we'll see that. So if it is one, that is a username, two is for password, three is for calling station ID. Calling station ID is the MAC address of the user device. That is a supplicant's MAC address information will be in the field AVP value 3. AVP value 3 means that is calling station ID. AVP value 4 is the called station ID, that is the NAD box MAC address. Supplicant's MAC address is calling station ID. The NAD box MAC address is called station ID, and the AVP value is 4 for that. Then we got NAS IP address of the switch or the WLC or the access point. Then framed IP address, service type, class, vendor specific information. Suppose if a particular vendor like Cisco or Juniper or any other vendor wants to send some information about that particular device, so that they can put it in the vendor specific attributes. Okay, vendor specific attributes, they can just put it. But I think this is not in the order, I guess. Yeah, I think these are not the proper values. Okay, well, this is not 1, 2, 3, 4. It is the number actually. So if you take the calling station ID, right? So the attribute value for that is 31. Calling station ID is 31. Okay, and the NAS IP address, that is 32, I guess. Then yeah. So these are not the actual values. Okay, please don't take that. So that's not the proper values. Um, hmm. No, sorry. This is same actually. AVP numbers are for username is one only. Oh, where is this? Ah. AVP value use for AVP value one is username, two is password, and four is NAS IP address. Okay, four. This is four. So this is not right. This is not in proper order. So I will share that to you in the WhatsApp chat. Okay, what is what? But these AVPs are very important. So usage of AVPs. What is the benefit of using these AVPs? AVPs carry the user credential, MAC address, or certificates. AVPs define user privileges, VLAN assignments, or access control list. Then for authorization. Okay, for accounting, how it is used. It is used to track session details like the start time, duration, data consumption. Okay, for start time also you got some AVP, duration and data consumption. How exactly? Let's check here. So this is the Wireshark capture as you can see. And here you can see the access request and the AVP is there here. So you can see NAS IP address is 4, okay. NAS port number is 5, AVP number, calling station ID, you can see 31, call station ID 30. So this is how the information will be in this packet. Okay, in this packet. So in this radius packet, so the AVP information will be put, and when you do the Wireshark capture, you can see what is what. Is there any vendor specific information? So vendor specific information, if you want to pass anything manually, so that's also possible in the Cisco ICE. Okay. For the vendor specific information, as I remember, it is 26. Okay, 26 is the value for vendor specific attribute if you want to add. Okay, so that's the attribute number actually for vendor specific passing the vendor specific information. Yeah, that's about the AVP. AVP. Next, moving on to the authentication in Cisco ICE. So as you know, EAP is the one that is going to carry, that is having the credentials, but to carry the information, carry the credential from point A to point B, we are going to use multiple protocols. Okay, we'll see one by one. So EAP is an authentication framework. Authentication framework used in network access protocols like WPA for wireless networks. It provides a standard for various methods such as token cards, certificates, and all. PEEP encapsulates the EAP with a transport layer tunnel, providing an encrypted connection to protect authentication. It often pairs with MSCHAP v2. Okay, MSCHAP v2 for password-based user authentication. So PEEP encapsulates with a TLS tunnel. Okay, PEEP is going to build a TLS tunnel, and it often pairs with MSCHAP v2 for password-based user authentication. So for the authentication purpose, you are going for the authentication mechanism, MSCHAP v2 is going to use. This combination offers security, strong security, as the inner authentication exchange happens within the TLS encrypted sessions. Then MSCHAP v1. It is an older authentication protocol, and it is used for verifying the credentials. Basically, it uses a challenge response mechanism to avoid sending passwords in plain text. Okay, the passwords will be hashed basically. PEEP with EAP TLS. This combination offers enhanced security by combining the advantages of the PEEP encrypted tunnel and EAP TLS certificate-based authentication. So tunnel also will be formed, and the authentication also will happen through the certificates. If you know about the certificates, there is CA certificate and the CA signed certificate, or it can be the self-signed certificate, right? These are the two kinds of certificates you can get. CA signed certificate is in your network, there will be a CA, that is a certificate authority. So you can install it in the Microsoft certificate authority or any other certificate authorities. For communicating internal applications like the any corp application communicating to the cloud or the SaaS based applications or internet applications, right? So what happens is we are going to use DigiCert or Entrust. So these kind of vendors provide the CA certificates or GoDaddy. So for communicating in the internet, if your internal application wants to communicate with some application that is through the internet, so then you need to have these certificates you need to get from the service provider, and you need to install it on your end. So normally the procedure is, suppose you got any XYZ application in your organization. So from there you are going to download something called as CSR file, that is certificate signing request. So that CSR file you give it to the CA. either to the internal CA, that is in your corporate network. In your corporate network, if a XYZ application wants to communicate with any other application, say ABC, then what happens is you download the CSR from both of them, give it to the CA. CA is going to sign it, and then again you get back that CA signed certificate and you install it here. And that forms a secure communication between these two guys. So if they want to talk with each other, it will be easy. So I am explaining this in a high level, not getting into too much deep. Okay. You can use SHA-256 and all. So that is, SHA-256 or any other encryption way of you can use it. But this is the, on a high level, this is what the concept is. You can use internal CA, you can use external CAs as well, right? If you are communicating over the internet, if you are communicating within your corp network, internal CA will be there. From there, you sign it. So that should suffice. If you want to communicate with the external applications and you want to have high level of security, then you can use the external CS. So that's what we are talking about here in the PEEP with the EAP TLS. The tunnel will be built, and also the encryption and the identity will be preserved through the certificates as well. So it's a combination. EAP TLS being the most secure but resource intensive, while MSCHAP V1 and V2 offer ease of use at the cost of security when used without encryption. MSCHAP V2. MSCHAP V2 is an updated and more secure version of MSCHAP V1, widely used in conjunction with PEEP. It strengthens authentication by introducing mutual authentication, meaning both the client and server verify each other's identity. That is the difference between the MSCHAP V1 and V2. Where MSCHAP V1, it just identifies the client, but here both client and server has to verify each other. Despite improvement for version 1, version 2 has been criticized for its cryptographic weakness. If you have worked on some certificates and all, right? So you might know what is cryptographic. Like you get some chains like SHA-256 or the DEFI health. What is that called as? DEFI Hillman um, algorithm, right? So those all things you can use. So both application needs to have the same. It should support the same crypto thing. Okay. So same algorithms they have to support. So that also negotiated, but it has very weak cryptographic things. Okay. Those algorithms are weak in the MSCHAP V2. So that's why they mostly being we are using PEEP. So then we got Leap, Eat Fast, and TTLS. So they are also doing the same thing, helping with the authentication mechanism. Leap was one of the Cisco's early protocols for wireless network authentication. It uses password-based challenge response system. It has become obstacle due to its vulnerabilities, okay, particularly susceptible to dictionary attacks. Then we got EAP-FAST. EAP-FAST is a Cisco's proprietary protocol designed to address the security issues present in Leap. Okay, Leap is a after Leap, PEEP came. Okay, Leap is a older protocol. So it creates a secure tunnel for authentication using PACs. So this is one important thing. Okay, protected access credentials. So this is what EAP-FAST is going to use. So this it can use it from many other mechanisms. Okay, protected access credentials. So as I talked about the of the identity and the encryption of the data is done by exchanging of the certificates, right? Similarly, there is one more way for identifying the other person in the network is through the PACs, okay, protected access credentials. So in this one, it is more faster because whenever a request comes from a client, if it is a having a certificate thing, then that particular client server who is going to contact this client is going to contact the server, right? So server and the client both has to go to the CA, check if they are if it is okay to communicate, then they are going to communicate. it puts a extra overhead in the network, right? But the protected access credentials are not like that. It does not require certificate, making it easier to deploy compared to EAP TLS. It is commonly used for wireless and wired network where a secure tunnel is needed without the complexity of certificate management. So this we will learn, okay, this we will learn CCKM and all. EAP TLS. EAP TLS is similar to PEEP as it establishes a secure tunnel using TLS. Okay, it is similar to PEEP, PEEP and EAP TLS, TTLS. TTLS, right? Transport layer security is there plus T. One more T is there. But with more flexibility in inner authentication methods, while PEEP is typically paired with MSCHAP v2. EAP TTLS can support a wide range of protocols such as PAP, CHAP, MSCHAP, MSCHAP v2 for inner authentication. It provides good security, especially in environments where legacy authentication methods need to be supported. Then we got the PAP, very, very old protocol. CHAP, very, very old protocol. PAP is a simple, less secure protocol that transmits username and password in plain text. Okay, CHAP provides a slightly more secure authentication method. It uses challenge response system, but that should also not suffice for the security. Okay, nowadays it is often used in legacy environments. It can be encapsulated in secure tunnel. So what we understand from this is one thing is building of tunnel. The first thing is holding of the credentials. Then we need a mechanism to authenticate, that is through the MSCHAP v2. Okay, MSCHAP v2, and then transporting those through the tunnel protocols like this is the mechanism to authenticate your credentials, and then you got you need to protect those. You are going to do it through the PEEP or EAP TTLS and all. Okay, that's the conclusion. So next, moving on. So here you can see the supplicants trying to connect through the EAP network. So they are going to secure tunnel established by PEEP. Here you can see authentication server, secure tunnel established. So people are trying to connect through Wi-Fi. There is a EAP protocol. So yeah, so it's just giving you an idea of how the supplicant and the authenticator and the ICE is going to communicate. Okay. This is the EAP framework. You can see the difference: authentication method, encryption type, certificate requirement, usage, where it is used, security level, popular for securing user credentials in wireless network, PEEP. Okay, EAP, you can see authentication framework that supports many sub protocols. So it is a framework actually. In that you got MSCHAP v2, MSCHAP v1, PEEP and all. So EAP TLS, EAP TLS is used certificate based authentication, strongest, secure, but requires complex certificate management. EAP TLS, EAP fast does not require certificates, easier to deploy than EAP TLS. Okay, EAP fast. So here they are going to use PACs, okay, protected access credentials. Okay. So then you got LEAP, EAP, TLS, PAP, and CHAP. So that's about the radius. Okay, we discussed in detail what all things happens in the radius. Radius and also this dot 1x, right? If you take dot 1x, all these things are there. But now we are going to learn about the map. This is when the device is capable to send the username and password. What if the device is not capable of sending username and password? Right? It is an IoT device. It is some electronic device that does not understand the login. It does not have a login page or somewhere where you can put the username and password. So in those kind of situation, for example, over here you can see a printer is there. So that particular printer is you cannot enter username and password. In those kind of situations, the authenticator, once the user connects, once the device is connected to the network, obviously this is ICE enabled or .1x enabled. So then it is going to send EAP request identity. It will ask for its identity. Like 3 requests it is going to send. Once it does not get the response, then it is going to do a MAB authentication. You should configure the fallback mechanism as MAB. That time it is going to MAB is going to kick in, and then it is going to take the necessary things, like it is going to create that AVPs, and then it is going to send to the radius. If it is going to match, so then it will allow further things. Time until you can see time until endpoint sends first packet after .1x timeout. So any packet. So you can see it is going to send 3 requests, then it is going to send the MAB request. So radius access request it is going to send radius access accept and network access granted. Okay, this is how the MAB is going to happen. Then we have different host modes. So we understood what is .1x, what is MAB. Next we are understanding what is different host modes, the endpoints that is going to connect, the supplicants that is going to connect to the network, so how they are going to connect, okay, and how that authentication happens. So host modes refer to .1x, how .1x handles the authentication of devices connected to a single network port. Cisco ISE offers several host modes to control how multiple devices or users are authenticated through a single port. When you connect a device to the SSID, when you connect a device to the wired network, okay, so how it has to authenticate and what is the host mode, that is what we are going to see in this section. Who is sending the AVP? There's a question in chat. So the radius is going to send the AVP. So as I told, so the authenticator, right? So he is going to put all those things because he is an intelligent guy, not the endpoint, right? So the authenticator is going to put all those values in the radius packet. I put the diagram, right, where it has EAP, again MSCHAP v2 or the PEEP. On top of that, it is going to encapsulate the radius header. So in that particular radius header, we are going to put the AVP. We, in the sense, the device, the NAD box is going to put the AVP attributes. In our case, the WLC or the AP is going to put that AVP things. Okay, when the headers, in that packet, right? So it will attach the radius header. So that will have that AVP. And also in the WLC, I will show you where you can change the AVPs. Okay. Derek, does that answer your question? Okay. So .1x host modes. So till now, what we have understood in a high level, like the supplicant, how it is going to connect to the authenticator, then to the ICE server, how they are authenticating and all we have learned till now. When the host gets connected to the network device, so it has got some host modes: single host mode, multiple host mode, multiple domain authentication mode, and multiple authentication mode. If a device connecting to a switch and this particular port it is connecting, a supplicant is going to connect. Only that particular device has to be connected to that particular port. No other device are authorized to connect. Okay, that is what the single host mode is. Multiple host mode is first device gets authenticated. The next subsequent devices does not need to be authenticated. Suppose this guy comes in the morning shift, he connects to the network, so he gets authenticated. His MAC address, it does a MAP authentication to the ICE server, right? So now the ICE server authenticates him. Next person coming in the second shift, third shift, so he is not required to authenticate. It will automatically get authenticated because the condition was to authenticate for the first time. That's it. That is a multiple host mode. Then multiple domain authentication mode. Multiple domain means multiple VLAN domains like VLAN 10, VLAN 20. Suppose it is a special case. If you have worked on the IP phones, like you get an IP phone, on back of the IP phone you get a small switch. So on that switch you are going to connect one more, only 2 ports will be there. One going to network, one going to computer. So here you are going to connect your workstation. This is going to the network, that is switch. So this forms a daisy chain configuration. It is called as daisy chain configuration. Okay, this is the IP phone. So now what happens? You are connecting to a single port, but the voice is on VLAN 20 and the data is on VLAN 10. But if you configure the switch port as an access port, you can allow only one VLAN. But configuring it as an access port, you're going to send VLAN 10 also, VLAN 20 also you're going to send. So this is a special kind of a VLAN, access VLAN that you're going to configure. Like two VLAN information you're putting on the same port or same access port, right? So how is it possible? You are going to use a concept of tagging and untagging. Whenever the packet goes from the voice, that is IP phone, it goes as an untagged packet. When the packet is going from the workstation or a PC, then it goes as a tagged packet. So that is the reason it allows both both VLAN domains here. So that's what this multiple domain authentication is. It is a special kind of a access VLAN where you're going to send voice and data traffic on the same port. And you can see this is the important piece. Independent authentication of phone and PC will be done. Although they are connected to the same port, if phone gets authenticated, PC is not getting authenticated, that will not work. It is separate. Phone also gets authenticated, the PC also has to get authenticated. So then we got the multiple authentication mode. Authenticates every MAC address in the data domain. One VLAN for all device per device DACL support. So morning shift person comes and connects to the port. So he also gets authenticated and authorized. Accordingly, he will get the DACLs, he will get the VLAN, he will get the access. Second shift person is going to come and connect. He also gets authenticated. Third person comes, he also gets authenticated. So all the devices are getting authenticated here. That's the multiple authentication mode. Single host mode, multiple domain host authentication mode, then multiple authentication mode. So these are the different authentication mode at the supplicant level. We have okay. As you can see here, based access control is implemented during the different stages of the network. Okay. Uh, so in ICE deployment, we got monitor mode, low impact mode, and closed mode. Okay. Now what happens? We know by now that Cisco ICE is a very, very critical component of the network. Unless you are connected to a Cisco ICE, you are not into the network. That's how critical ICE is. So when you are implementing it for the first time, suppose you bring a Cisco ICE, you connect it to the network and you enable all the NAD boxes for the Cisco ICE. Is it going to work in existing setup? No, right? So first what you need to do, you need to collect the information. Like what type of devices are going to come and connect? What protocols that they are going to use? What is the version that they are on? So all these things you need to analyze for some time before jumping into the implementation. Going live, right? So before going live, you need to get this information. Once you get this information, you can write rules, right? You don't know your environment, you come and put the eyes, so that is not going to work. So that's why there is something called monitor mode. You can put eyes into monitor mode where it analyzes data, like it will authenticate everything. All devices it will authenticate in the initial stage. But with that, what we are doing is we are analyzing what kind of device is coming, who is coming. Okay, so all those context aware data it is going to collect. So upon collecting, so the admin is going to put the rules, so then he is going to enforce the rules. If you have worked on Illumio, there is a product called as Illumio, right? So You can first, it will analyze, then it is automatically going to enforce the policies and all. So similar way the ICE is also going to work. Like initially it has, you have to put as an admin into a monitor mode, analyze everything, and then you can enforce the policies or enforce the authentication or authorization profiles you can put it on. Okay. So next, monitor mode is used for observation and monitoring without enforcing any access control policies. This is what I was talking about. Even failed authentication will allow access. Network administrator can see who have failed, resolve a problem before causing a denial of service. No effect on user or endpoint access. AAA radius accounting provides visibility into .1x operations. This is just the config that is required on the port level. Then low impact mode, limited basic access prior to authentication. Port ACL applied to the switch, default port. Suppose if any authentication fails in the second stage, right? If authentication fails, give him limited access. In the first step, you're giving full access even if the authentication is failing. The next time, once you start into low impact mode, then basic access you're giving prior to the authentication. Then the closed mode is the last mode where no access prior to login. Specific access after successful authentication. .1x behavior, most restrictive method. Then there is a licensing thing. So how the license is consumed, what kind of licensing it follows, like the essential, advantage, premier, device admin. So these things. So this one we will check out in the next session as we are all almost top of the hour today. So we will check out in the next session. Okay, how the smart licensing works and all. And also we will start device administration from tomorrow. So before winding up, I will just share what is happening on the ICE server. It looks like the ICE server is still installing. It has got, it was supposed to install in 15 minutes, but still it is kind of installing. I think the ESXi needs a reboot, I guess, because it's very slow actually. Still, it is in installing state. I will leave it like that. Tomorrow, when we come back, it should be going to the. It will prompt for username and password basically that we can see check out in the next session. Yeah, I think it's time to wind up now. So we can continue tomorrow. Tomorrow we will just once the ICE is installed, we will log in. We will go through all the tabs on a high level. We will see what is there in the Cisco ICE configurations. We will see some basic CLI comments, what we can run. We can look at that, and then I will explain you what is the device administration, how the licensing consumption happens. So those things we can check out in the next session. In the on Wednesday, we will do the full-fledged lab where I will integrate the AD server with Cisco ICE. Then we will add the WLC and AP into Cisco ICE, and then we will register a client on to Cisco ICE with we'll write some authentication and authorization rules, and we will connect the clients to the Cisco ICE. So that's the next step that we will do. And once that is completed, so we will learn about the profiling and then different trust sec profiling. And the important one is the guest access that we can practice. Okay.